you work with them as parabolas. So that's what they are, right? Parabolas come in two forms. Up like a cup, down like a frown. Depending upon what was going on, you also found other things within them. Lately, we've been finding zeros. We've been solving equations and figuring out where the zeros occur. So you're figuring out what something, when x is equal to 0, what's their y value, and so on. Or excuse me, when y is equal to 0, you're getting your x value. The other things that you're going to be doing is you're going to be finding what are called maximums and minimums. Depending upon the parabola, it'll either have a maximum or a minimum. For example, will that point there be a maximum or a minimum? It's a minimum. Now, what's counterintuitive of this is that parabola a positive quadratic or a negative quadratic? It's positive. Positive quadratics have that first term that's positive, so they're up like a cup. So it's kind of weird to think that it has a minimum value. So there's a minimum value that occurs with a positive quadratic, and therefore a maximum value that occurs with a negative quadratic. Okay? So what we're going to be able to find here are what are going to be the maximums and the minimums. This is very, very common stuff in just about any modeling that you do. Kicking a ball, hitting a golf ball, shooting a cannon. I mean, seriously, it's all about trajectory, and everything, what goes up must come down because there's some sort of initial velocity. Right? You ever heard that before? Yeah. Initial velocity, how fast something's being thrown out, as opposed to just being dropped. Okay, so it has a left to right component to it. So what we're looking at here is how do these things work? One of the easiest things to think of is when you are, now I'm not going with specific problems yet here, is that if you start here and you wind up here, this value would be your maximum. Do you agree?
Yes.
Now that maximum, if you think of it in terms of x's and y's, what would this value tell you? What would that tell you? Just thinking about something being like a cannon. Maximum height, yeah, exactly. You can figure out what your maximum height is. You can figure out, a lot of times with quadratics, they can model sales. If you're selling something for $10, you can sell 20 of them. If for every dollar you increase the price, you sell one less. That's still modeled by a quadratic, and you can figure out what would be your maximum setup. Yes, sir? Oh, I think I about this question. All right. So what I want to do here is kind of walk you through a couple of style of these problems and give you guys a mixture of them to work with. For example, it's a quadratic model that's right out of your book. I think this is in section 5.2. I forgot what page it was. I say 259. If you wanted to read it in there. Yeah. It's on page 259. Just a very simple idea. And what they're saying here is you maintain a music-oriented website that allows subscribing customers to download audio and video clips. When the subscription price is $16 a year, you get 30,000 people to subscribe. For every dollar you charge more, you expect to lose 1,000 customers. How much should you charge to maximize your annual revenue? And how much would that be? So, when you read something like this, they're telling you, I think I cut off the part there where it's saying that it is modeled after a quadratic. So that basically is telling you 2 bits of info. It's telling you that you have something that costs $16 per year, and you start out with 30,000 subscribers. It says for every dollar you increase, you lose 1,000 of the customers. So what do I have to do to that 16 to make this into a term? Am I multiplying or adding? Adding. So for every dollar I increase, I'm losing, oops, should be an extra 0 there. Okay? And that gives me some nasty, awful looking quadratic. Do you agree? Well,
X is $1.
yeah, think of it this way. For every dollar I charge more,
Yeah.
I lose 1,000 times that in customers. So if it goes up $2, I'm losing 2,000. If it goes up 3, I'm losing 3, and so on and so forth. Okay? So what you guys want to be able to do is figure out what this is looking to do. Well, here, I want to maximize something. I want to maximize my revenue. I want to make the most money. So, I don't know about you, but I'm not going to multiply that out and write out some crazy formula to figure out what's going on. I know it's going to be a quadratic. I know it's going to have a maximum. So what would my graph look like? Down at the front. No matter what, my graph is going to look something like this. It's going to cross the x-axis where and where? Is it 16 or negative 16? I'm sorry, I probably this one. It'll cross it at negative 16 and 30. Does that make sense? Solving for my zeros.
So you divide by negative.
Okay. Set them both equal to 0. So you have 30,000 equals 1,000x, just divide by 1,000. So I know that somewhere in my graph, this point's negative 16, and this point is 30. Somewhere in between here and here, there occurs an ordered pair for our maximum value. This is where the graphing calculator becomes your best friend. Here's what I want to do. Go to your y equals table. Let's change my window real quick. And we're going to put that in exactly the way it looked. Parentheses 16 plus x, parentheses 30 minus 1,000. Okay? And I'm going to go to the graph. It should be there, shouldn't it? And that's what I'm wanting to start showing you guys how to make your windows move. Because I don't think we haven't done a lot of moving the windows around. So here's where we know there should be some graph. We know that the zeros, because it was easy to find, should occur at negative 16 and at 30. So what I want to do is press the button that says window. We're going to adjust this. All right. We know that the value for 0 on the left-hand side was negative 16. So I'm going to change my my x minimum value to be, let's put it at negative 20. My maximum, I know it crosses at 30, I'll make it 35. That way I can see it a little bit clearer. Everybody okay with that? Right now you got 2 lines. Okay. So now we're going to figure out where the maximum occurs. So we have to adjust we're going to adjust the y maximum or the y minimum. Okay. Scroll down. Just start picking big numbers. I chose 50,000. It's fine. Go again.
Add like 3 more.
I'm going to do 550,000 just for argument's sake. And oh, look at that. It worked. I knew because I did it last hour. Okay. Yeah, sometimes it can just get nasty and you get really crazy numbers. Okay. So just by knowing that moving the window around, I can finally see my whole curve. which means that I know that if I'm looking at this correctly, here is that maximum, here's that negative 16, and here's 30. The calculator will solve it for you. What I want you to do is I want you to press second calculate. Calculate. Okay? Does everybody see the button you're going to press next? Maximum. What's nice is that the graphing calculators will allow you to find zeros and maximums and minimums, intersection of two lines, things like that. But you have to tell it what to do. If I press that and it asks me now, what is my left bound? This is going to be a little bit difficult to see in this case, but do you guys see your cursor blinking toward the top of that curve?
Yeah.
Okay. What you're doing in this case is the following. You're going to choose some point to the left of the curve, top of the curve, and some point to the right of the top of the curve. And what the calculator does, it's going to figure out what is the largest value between those two. And that's how it does this, by pressing a couple of keystrokes. So right now it looks like it's centered at the top. I don't want to pick the very top. I want to move to the left a few buttons. See how I'm starting to come down the curve? You look at it closely. Remember, this is difficult because that curve is way up top, okay? So if I hit enter, you'll look now on the screen, it says right bound, and you'll also notice on your graph that little arrow. You see that? That arrow means it's going to look for values to the left of where that is. So now you have to move your cursor to the right side just by moving it to the right a bunch of times. It doesn't have to be symmetrical, not at all. As long as you're to the right and to the left of that curve, that peak, you're fine. Hit enter. It says guess. I have no flippin' idea why it says guess. I don't know what it means. Not at all. And I hit enter one more time. And it gives me my maximum value at 7 for X and 529,000 for Y. Yeah, that's fine. You're with the, and what you want to start to remember is this is asking it like for every dollar. So if it's coming out as 6.999999, how much is that? $7. So your maximum rate that you can increase it will be $7 more. And if you do that, you'll have 529,000 subscribers. Yes, sir?
Stuff like this can be in the test.
Yeah. And the question that comes up a lot of times with word problem stuff, it's not that it's going to be really difficult to extract the info, it's how do you use that info. And it's, you can see this isn't a really difficult problem to set up, it's just new, all right? Same thing goes for a lot of these types of word problems, and you'll have some of those tonight for homework, is that they will give you the quadratic model. They'll give you the formula. You have to interpret that to solve for what it's asking. Whether it's asking for a 0, a maximum, or a minimum. All right. Does that make sense? Yes, sir. Well, those were just the zeros from the original equation. We know that these two are these are the terms. What are the zeros? Well, if my term is 16 plus x, my 0 is 7. That's all it was. Yes, ma'am.
How did you get that the subscribers was 5,000?
If I'm using the value of x, remember the question was asking us how much would you increase and then how much, oh, not subscribers, revenue. That was revenue.
Thank you.
I'm sorry, I misspoke. It was revenue, how much money you were making, not subscribers. Excuse me. Thank you. Yes, sir.
Is it always going to work out where the X value and something like how in this case it was 7, how it's exactly in between like the it's exactly between the zeros?
What's happening here is that you have what's called an axis of symmetry.
Yeah, 'cause it's right here.
Right. Your vertex lies upon the axis of symmetry. It just so happens that when we model some things with some of the formulas like this, working with the axis of symmetry equations tend to be a pain in the butt.
How come it came out as 6?
What's that?
How come it came out as 6?
Rounding error.
I got 7.
Yeah, it just really depends on how far over on each side of the curve you go. Okay.
But it will be about 7.
Yeah. Let me do another equation here, just to get you guys an idea of how you can use the calculator to find maximums and minimums. So it's a little bit clearer. Yeah. It's okay. It's fine. It should. It should be all right. We'll get there. Let's do another one with working with the calculator. Go back to your y equals, clear it out, and let's put in the following equation. I'm going to help see if you guys can get minimums and stuff. Oh, first of all, what I want to do is reset our Zoom. Oh, better yet, how about this? Do you guys know how to reset the calculator? There's an Achoo button. Not through that one, not like the old ones where you just had that reset button. How you reset your calculators is that you do this one first and then you do that. This is how you reset. This happens all the time. People get, in their problems, if you're finding these maximum and minimums with your parabolas and stuff like that, it's very easy for the calculator not to get reset to a normal setup. What you want to do is go back and set the defaults. And in order to do that, you just press the following. Second plus sign 712. Second plus sign 722. When you do that, it resets it, it clears it out, it takes away all that RAM, whatever was just recently stored in it, and clears it up. This happens all the time. When you guys are in like science or something like that, and you're using these graphic calculators, you'll do a lot of stuff where you're going to change your parameters, change your windows a lot, and when you come back into here, you're like, oh, where is it? I don't know what to do, I can't find it. I'll just tell you to reset your calculator, and it'll come back. For those of you guys that were graphing, you're getting weird stuff, where sometimes you get like an error message where it says like invalid DIM or invalid domain or something like that. Sometimes it shows up on the calculators with that because when you enter in your window, if you don't put the signs correctly, it's very easy to make that error. So if you can't figure out what you did wrong, reset it and start over. It's probably okay. All right, these calculators are very, very finicky when it comes to older graphs and stuff. Yes, sir.
I got press alpha 1, F1 to that forward locate shortcut menus.
Yeah, and then up here, the next line says press something and not see this menu again. All right, so let's do this one. It is 12x squared minus 25x minus 7. Go to your y equals 12x squared minus, oh, was it 25? Yeah. Bless you. And I want to graph it. Sorry. 12x squared minus 25x minus 7. All right. I want to graph it. Once again, there's two ways you can go about doing this to find that minimum value. Since that minimum value looks like it's just going to be a little bit down there, if you tilt your calculator just right, you will see it.
Oh,
That's awesome.
Oh, I thought you meant like either way. Yeah. Minus 7.
Oh, calculator humor. Great. And I was trying so hard not to go too fast through that, just to see how many people actually did it, and you were the first one that did it. Anyway, change your window. What do you have to adjust here to see where your minimum is? The Y minimum. So here, since we all know that it's up like a cup, there'll be a minimum value somewhere at the bottom. All we have to do is just pick some Y value that's smaller than negative 10. Try negative 20, negative 30, just so you can see it. I put negative 30. It shouldn't matter. When you do this one again, what we're going to do is we're going to find the minimum value. So you hit second trace where it says calculate. And now we're going to hit minimum. Okay. Remember, left bound just means you want to be on the left of the lowest point. So I'm just going to move mine over a little bit so it's a little bit closer. Hit enter. Right bound has got to be to the other side of the curve. Hit enter.
Mine's not. My arrow, like, is that-
Are you using the left and right cursor or up and down? That's fine. All right. Hey, you're going to get weird decimals on this one, which is perfectly fine.
It's like, why did you say that?
Yeah, this one here you should get really crummy looking decimals because if you factored that problem, you get really crummy zeros. So it's not that you're always going to have perfect numbers for your x's and y's for your maximums and minimums for that vertex because your zeros can be placed upon anything. All right. So just kind of what I'm looking at here is just trying to give you guys the idea of how you move through these things. Okay. What's that?
Sorry, my battery wasn't
Oh. See, the other one that I wanted to look at. Where is it? Some of these problems, like I was saying, some of these problems are going to give you some function, some words that make sense. It's really, a lot of this stuff just stems from being able to see if they're asking you what is the maximum height, what's the highest value. It sometimes might model out where it might ask you how long something is in the air. Or it'll set it up as, time is given, what was the height at that time. It's a matter of using the calculator. The calculator does a really good job of working with these modeling style problems. One of the things that I have set up, hopefully for Friday to work out, is that we're going to kind of create our own model and just I hope that it works. And we'll be using the calculator to help us show the equations by giving a bunch of data sets. So we'll see how it goes. But let me just give you some problems to try out. So far, I don't think this is going to be anything so scary. It's mixed over the course of 3 sections. So, yeah, I kind of went back into the sections themselves and did the word problems separately because they're all kind of the same idea. Just I figured do all the work up front and come back to do these. 5.2 is page, so it'll be page, what is that, 261 probably, I think. I don't know. That is numbers, at least 262. 98, 101. 55 was 280, 287. This would be 288, I bet. Nah, it's not that bad. It's like 13 problems. Yeah, that's the whole idea. And then page 2, I think it's 297 is the next. It's right in that same ballpark. Let me just double check those page numbers for you guys. I believe those are correct. Oh, it is 296, sorry. It's 296. Sorry. I'm just checking the page numbers, make sure I have them right. I was guessing 288. Starts at 287. I know. You would have gotten the right idea. Was it 262?
Yeah.
Okay. Hey, 1 out of 3 ain't bad.
Yeah, that's a good We
Talking about
have to
baseball
partial
batting
credit
average.
while
If I have a 333 batting average, that's pretty good.
We're not talking baseball.
All right.
Did you really game us or Friday?
We were about to, but both of my kids were just wiped. We didn't get a chance to go. They were just toast. They had school all week, and they had no interest in going to a game.
This is the first time in like school ever.
Oh, I know. I mean,
There was like 11,000 people there.
yeah, I heard. That was pretty cool.
Yeah, they're gonna represent
It's the second time in
The Shane County.
years.
Oh, so you're funny.